Okay, so here are some of my measurements and diagrams to start off with. All these measurements are in centimeters. I didn't put the units on every single one. So I split it up into 5 diagrams. The top of the table here, this is the bit underneath the table, as if you were looking up from the bottom. This is the footrest thing, but I've taken out all the curvy bits things. I think there was 12 of them on the table. So you see I've drawn that down here. So they fit there, and underneath the table. And the legs of the table are here. So my measurements are probably in around the same as yours. So for instance, 80.5 for the width and 50.5 for the length and 1.7 for the depth of the table. Killing.
Mr. Carter, can you cross mine out? I just remembered I forgot to add a number.
Okay. I'll do that in a second. All right. So I'm going to go very quickly through the surface areas and volumes of each shape. Let's start with the legs. Where's the legs? Here they are. So make sure you pin this to your screen. So we're going to work on the surface area. So the surface area, SA for short, we're going to get, so 78.5 times 4 will give us one surface. 78 times 4. Okay, so that will give us one of these surfaces. And of course, there's 4 of these surfaces on each one. All right, and that gives me 1, 2, 5, 6. Now, you can adjust, and I adjusted slightly for where they join. So there's a join up here that wouldn't have been painted. So I said as if it was painted, and I didn't include the top here. I did include the bottom, and I'll show you in a second how I include that. But there's 2 surfaces that would have been joined here and around the back. You can look at your table when you see that. So I subtracted a little bit for that. I did. They are 4 by 4 squares. So minus 2 4 by 4 squares. So that's minus 2 times 16. And so I got a 1, 2, 2, 4 for the surface area of each leg. And then I multiply that by 4, of course, because there was 4 legs of the table. So there's 4 surfaces on the leg, and there was 4 legs on the table. Just the side surfaces. I'm not talking about the top and bottom. So that gave me a surface area of 4896 for the surface area of one leg. Now, interestingly, that underneath part I was trying to include to be painted, but if I'm looking at the underneath of the table and I just look straight down at the table, that would be included in the bottom of the table. If I just did the bottom of the table as a full thing, all this underneath of the table is actually included when we do the surface area in the bottom of the table, because it's the same surface, same size of surface. Now, I can explain that more when we're looking at the table tomorrow in class. Was this supposed to be a complicated challenge? Yes. Of course. Yeah. All right. So that's the surface area of one. The volume of the leg then would be 4 times 4 times 78.5. So 4 times 4 times 78.5. And then there's 4 of those legs, so I multiplied it by 4. So its answer would be 5024, and that's centimeters cubed, and that's centimeters squared. So we have 2 answers to start our volumes and surface areas. The volume, I'll just highlight here in yellow, and the surface area. Okay, so there's our volume and surface area of the leg, for example. All right, so the bit down here, the footrest, is, well, these are just rectangles, aren't they? They're just rectangular shapes, so you can get, as long as you have that this is for they were obviously made from all the same pieces of wood, just the different lengths. It was 4 times 4 for all those pieces of wood. So that was good design by the designer. If you think about it, he just had, or she just had a lot of this 4 times 4 wood, and then, So I'll talk about how close it is in a second. A lot of this 4 times 4 would, and then just cut bits out of it and then join them together. Now, how close you are, of course, my answers are not perfect. Your answers are not perfect because the human eye is the difference. If you adjusted slightly differently your ruler, or you got a centimeter less, or half a centimeter less, or even a millimeter less, it would affect the whole thing. Does that mean your answer is right and my answer is wrong, or the other way around? No, they're both good estimations of the volume and surface area. If you're in or around, that's what we talk about later on in this unit. We'll talk about percentage error. Okay, so a lot of people have got similar answers. Anything around this is a reasonable answer for both. Katie, you have a question?
I'm so sorry, Mr. Carter. I forgot to write it down.
All right. Okay, so the volumes and surface areas of this bit here. So the volume, I'll speed this up because it's just similar multiplications here. It's just 2 of these and 1 of these going across, and they're quite similar to the underneath of the table. So I kind of combine them all into one and then add them together. So it's just all just multiplying length times width times height for the volumes here. Okay, so the volumes of all of this and this put together, all those rectangles I got, let me see, can I read my own writing? So if I just do this bit, this section, and then these 2 sections together, I don't know, hopefully that makes sense to you, I got 3,168 centimeters cubed. So it's just 66 times 4 times 4 times 3 of these sections. So I estimated no, you don't need to write this down. Don't need to write this down. It's going to take too long for you to write it down. Just watch how I did it. Because your task for this unit is going to be similar, not as hard as this, but similar to this. So it's the method, what way I did it. So the first thing you should notice is that when I did it, I split it up into different shapes that I knew I could get. So when I drew a diagram, I split it up. And then I looked at similar shapes. So this shape was similar to the 2 bits underneath, so I got the volumes of those. So that's the volume of 1, 2, 3 here. And then if I do the 2 sides, they were similar as well, and added them together. Apparently I haven't added it yet. So they're the straight bits. The 4 sides here, I got the volume to be 3,408 centimeters cubed. Okay, so they're the 2, that's the volume of this, and this. Now I have not included these corners of the legs here on the underneath of the table because that's already included in the legs calculation, which I did over here. So this bit I'm shading in here is not included. So this 35 only runs from here to here, and this 66 only runs from here to here. Okay. All right, so there are the 2 volumes. So volume, I'll do in my volume color. For surface area, so that's the volume of this and this. The surface area then, similar process, just loads of surfaces here, aren't they? And I calculated that all those surfaces together would have a surface area of 2,272 centimeters squared. Those surfaces, all those surfaces. So it's just loads of multiplications of lengths times width. I won't do them all, obviously, because it'll take way too long. It took ages. So, like, for example, this is 66 times 4. This 66 times 4 here, and then I kept on just adding bit 66 times 4 there. That would be 35.5 times 4. Okay, and I did all those areas and the underneath of the table. Now, for the underneath of the table, I only did the sides. Because if you think about it, once again, this is all about point of view. If I looked at it from underneath, a lot of the sides, the bit you're looking at, it has been included in the top and bottom of the table, which I'll work out in a second. Okay. All right, so the surface area of those is that. So I'm just trying to get to my answer relatively quickly. All right. And the top and the bottom of the table now, they're quite large surfaces, aren't they? So we're expecting the majority of the table to be in this. So the volume of it is going to be 50.5 times 80.5 times 1.7. So a lot of you should have got pretty close to that. And I got 6,011 for the volume, just multiplying length times width times its height. So a lot of you probably should have got a similar answer to that for the volume of the top of the table. The surface area of the top is a little bit trickier. It's 50.5 times 80.5 times 2. So that's the 8130.5 if I do those two. And then there's a load of surfaces around the outside here. So 80.5. Oh. Sorry. So 80.5 times that 1.7 I have here. So there's a surface here and here times that by 2. And I get 273.7. And then this surface here and this other surface on this side would be 1.7 times 50.5. And that's his, sorry, I hadn't done these out, I just did them all as one. And then when I add them together, I will get the final surface area to be around, what is it, around 8,000, just checking my answer here. Yeah, it's 8575.9. That's the surface area of the top and the bottom combined. So it's a lot of surfaces. All right. Now we've one final bit to get the surface area is. That's okay, Sal. That's okay. It's the method that matters, not the answer. As long as you have the same method, that's all that matters. If your measurements are different, yeah. So my measurements might be wrong. Yours are probably more accurate. I rounded a lot of mine just to make it easier. Okay, so there's 12 of these Kirby bits, I think, in the table. Now, it was interesting how we dealt with this. I thought a triangle was probably the best idea, but of course a triangle, it's not really a triangle, but it is the shape that best fits that shape that we know, okay? All right, so I got a 7 by 7 triangle. So the area of one side of it would be 49, 7 times, oh, sorry, and including both sides. If you look at both, so I'm doing the surface area first. It's 49 divided by 2 this side, and then the other side, if you look at the back of it, it was 49 divided by 2. So that would just be 2 49s divided by 2, which is 49. So surface area of one of them, just the sides, is 49 centimeters squared. Now I need to multiply that by 12. Now what about the kind of curvy surface that we look at? No, I think there were 12. 1, 2, 3, 4, 5. Oh, maybe there's only 8. No, there's 12. No, there's 12. If you can come in and look at it tomorrow, but there's 12 of them. Yeah, you'd think there should be 8, but there's 1, 2, 3, 4 here, and then underneath the table there's actually 8 of them. So you can check that tomorrow, because there's one in each corner. 1, 2, 3, 4, 5, 6. Oh, you're not looking 7, 8. There's one in each of these corners. Okay, so that's the surface area by 12. I didn't include this curvy surface because if you look, I've included it already in many of my calculations. I've included it in the underneath of the table, the leg of the table here, the curved bit is here, and it would be included in the corner here. It runs from here to here, and I've included it already. Okay, so 49 times 12 gave me, oh, I did this on the board. 49 times 12 is 588. is the surface area of that. Now, adjust down a little bit, because of course, this is not a complete triangle, so you can adjust it down as much as you want. And this is an estimated adjust down. I'm going to adjust down maybe for each one, maybe 5 or 10 centimeters squared. I think 10 centimeters squared for each one. So I'm going to actually take away 120 just to adjust down. And that's going to give 468. Now that's an estimation. That's very much an estimation. So if you didn't adjust down, that's okay. All right. So that's the surface area of the curvy bit. And now we need to finish off and get the volume of the curvy bit. Now that we treat it as a prism. So area of the front section is going to be 7 times 7 divided by 2. That's the area of the front section. And if I multiply it by how deep it is, and it's 4 centimeters deep, that will get me the volume of one of these. So remember, that's how we do it with a prism. Get the area of the front slice and then multiply it by its volume. I'll have that written somewhere here. I do 90. That's 98. Oh yeah, 98 centimeters cubed for one of them. Now adjust down a little bit again. This time I'll do it before I multiply. Adjust down a little bit. Oh, I'd say each one, maybe just make it a nice round figure and take away 8 centimeters cubes from it. And that gives me 90 centimeters cubed. So this already is making my answer different than yours, because you can estimate different than me. So, and then multiply by my 12. 90 times 12. What's 90 times 12? Anyone? No, you're an extra 8 there, but it's 108 and then the 0 afterwards. Centimeters cubed. So that is my volume of those little bits. Now, oops. Whoa. It's a lot of things to look at. So maybe you can zoom out a little bit here and see my entire piece of work. So at the top here, I'm going to add up all the bits and then get a final answer. And it looks like it's going to be quite a large figure. Definitely over 10,000 for both, I think. So totals. Surface area. I'm going to add them all up, and volume. I'll add them all up and then get a total. I'm going to put it down here. Okay, so for volume, I have one volume here, 5024. Another volume here, 6711. I have a few volumes down here at the end, 1080. And 2 volumes here, 3168. 3408. Okay, there are my volumes all there. Surface areas, I'll do the same. 4896 from here. 8575.9 from there. I have one down here, 2272. And 468 from down here. So it was nice that I color coded them so I could find them quite quickly. Now, come to the final bit of it where I add them all up. So this is why you need a calculator for this. Well, you could probably add these okay, but a lot of the calculations, especially with decimals and stuff, you just use a calculator for them. That's a 246711 plus 1080. That gives me a total volume of 19,391 centimeters cubed. All right, that's the total volume. Total surface area then. $16,211.9. Okay. Centimeters squared. So there's my two final answers, and now let's transfer them over to the other page and let's have a compare them to your answers. Okay. So back to your answers. For the volume, remember my answer was 19,391 and 16,211.9. Let's round that off a little bit. Okay, so now I'm not saying that that is the correct answer either. I am saying that's my estimation. So as you can see, it kind of falls in between our highest answers here, 24,000, and our lowest answers, 7 and 9. It kind of falls in between them, which kind of makes sense. I think Pauline and Julie got the closest. I think definitely the best diagram I saw was Tao's. He sent a great diagram to me. So that's the best diagram I saw. But yeah, Pauline and Julie, super close on the volume here. That's so little. If you think about that, you're about 400 centimeters cubed away, and that's about the volume of maybe a remote control like that maybe about 400 centimeters cubed. So that's really close to what my answer is, and maybe your answer is right and mine is the wrong one because you probably had better measurements than me. Now for surface area, I got around 16,000. I think Lauren is the closest here. Lauren got really close with 2,000. 2,000, about 2,000 off, so well done, Lauren. Pauline and Julie, quite high there. I think you may have included a few too many surfaces in that one. But yeah, so around a lot of the other class got around 12,000 as well. So I think it was just the sheer number of surfaces you had to include. And yeah, so for instance, if you only thought there was 8 corners, it would have been off. So yeah, so well done. I think yeah, Lauren closest to me and Pauline and Julie closest to me on those. So well done to you guys. Was good job. Okay, so just for context, 19,319 centimeters cubed is about 19 liters of water. So if you imagine, this is 19 a bit liters of water. So imagine if your desk was actually hollow and you poured water into it, would it fit about 19 liters? I think it might. If that makes sense. If you just think about the leg alone looks like maybe fit a couple of bottles of water in there, wouldn't it? Each leg, so that'd be maybe a couple of liters. And as we saw, well, it's not quite. Oh, we have it here. It's not quite. It's 5,000 for 4 of them. So if I divide that by 4, it's actually only about 1.25 liters per leg. So you can think about that. If you want to think is 19 liters of water. Now that's a good way of visualizing it, perhaps. And the 16,212, if you want to compare that, well, what's 1 meter cubed in centimeters? 1 meter squared, sorry, in centimeters squared. What's 1 meter squared in centimeters squared? Can anyone remember? What's that conversion?
100 centimeters squared.
Nope. That's 1 meter in centimeters. No, it wouldn't be 10 centimeters squared. So you might need to look at your notes. If you have your notes, you should have a conversion between centimeter squared and meter squared and meter squared and centimeter squared. You need to do something twice. So to get from here to here, you multiply by 100 twice. What's 100 times 100? It's one of those, all right, Usher? It is 10,000. So 10,000 centimeters squared is 1 meter squared. So remember, 1 meter squared is about half the size of one of the whiteboards in my room. Okay, so if we unfold the table and took all those surfaces apart, it's going to be about it wouldn't fill the whiteboard in the room. So for a reference, it wouldn't fill the whiteboard in the room, which kind of makes sense. You can see where I did this yesterday with the other class, if you look closely. And but it might fill 3/4 or 2/3 if you unfolded it all, perhaps. So it kind of makes sense. So just a reminder, this is what a table looks like. That's what the board looks like. So you're thinking about, the top and bottom might fit half in the board, and then the rest of it might fill another 1/4 of the board. All right. So it's good to reference your answer to see does it make sense before you finish any one of these challenges. All right. So today, that took a while. Today we're looking a little bit at circumference, a number called pi, and circles. All right. So first things first, if you have use of a compass, or yes, now you start taking notes. So if you've use of a compass or anything round, get it now. That makes, so most of you probably don't have a compass, so you can use the bottom of a glass and try and make a good circle. So I'm using a compass. That's what a compass is for. All right, so try and make a circle. If you don't, just use the bottom or top of the glass, and you can use a glass or whatever to draw this. This obviously is a circle. So I'll give you a second to draw a nice circle. If you don't have it, something perfectly round, you can just draw it freehand. Classically, Leonardo da Vinci was able to draw a perfect circle freehand without any assistance. So here's my attempt to do it freehand. Yeah, not good. So it's better to have something round, so you use sellotape or a mug or the bottom of your water bottle or something in your notes. Okay. So a circle has a number. Oh yeah, I haven't seen that. Yeah, Lucas, go. Okay, so now I'm going to get my ruler out and I'm going to draw a line through the center. So make sure it goes through the center-ish of the circle. So I know yours won't have a dot to say the center, but that is the line I want to draw. One line I want to draw. Okay. What's this line called? Can anyone tell me? The line that goes through the center and goes from side to side? Nope. So the center line that goes through the center? Nope. Asher knows the radius is half of it. Yes, it's the diameter. So that's the diameter. Goes through the center and goes from one side of the circle to the other side of the circle. And Asher's on the ball. He says the radius is half of it. So the radius, so in general, the diameter, and all this should be in your notes, equals 2 times the radius. So the radius is the line that just is half a diameter. So it goes from the center, and yes, this has to go in your notes too, just from the center to the outside. And that's called the radius. The radius is used more often than the diameter. Well, so usually. So what's the radius? It's the distance from the center to the outside. Okay. All right, yeah, so all of this must go in your notes, hopefully without my bad circle down here. All right, so what is this? What is this? I see someone bringing up circumference. Pauline, you said the circumference. Can anyone turn on their mic and tell me what a circumference is?
Circumference is like
Just a second. Sorry, there's an echo. So the circumference is basically the outside of the circle, not the outside, but like the line that goes and makes.
Yeah. So the circumference is the distance all around the outside of this circle, all around the outside. All right, so I'm going to put the It's a special word for the perimeter. So we usually use the, yes, exactly, Asher. It's just a special word for the perimeter. So the circumference is the perimeter. So just put that down here. Okay, it's the perimeter of the circle. So you can write both those into your notes. Put it on the diagram and put it down here. All right. So anyone tell me, I want to measure the circumference. Now I don't have any dimensions on this. Anyone have a way I can measure the circumference of this circle? You have an idea? Asher?
I don't know if this is the area or the circumference, but I think it's the radius times pi.
Oh, I don't know what pi is. So I'm saying just looking, if I just was given a circle, and I don't know what pi is yet, no one's told me what pi is yet, and I haven't a clue what's going on and what pi is. Yeah, but I don't know what the radius is either. Anyone tell me a method I could use? You're all in the 3.14 brigade. Yeah. Okay. No one has this? What happens if I introduce a piece of string?
Use the string to measure around the set.
Yeah, so string is a malleable shape. So if I try and use the piece of string here to measure around the outside of the shape, like so. Now it's not. Oh, you did this, and yeah. Well, let's do it. Oh, okay. So that's pretty close. You can see there's some errors, but I think it's about to here on the string. So what do I do with the string now?
You measure it.
Yeah, I'm going to measure it against a ruler. Okay, so I'm going to take out my ruler and I measure it. And, well, you can't see me do it, but it's about 27 centimeters. So the circumference, and you can stop taking notes now. The circumference of this circle, running out of space here, so just put it over here. The circumference, now what unit will that be in? Is it 27 centimeters squared? Okay, no one? Okay. 27 centimeters. Okay, that's my circumference of this circle. Now to measure, I'm just going to measure the diameter. I'm just going to measure the diameter and see what this diameter is. Oh, okay. So it's about, I'm going to say around about 8.4 centimeters. 8.4 centimeters for the diameter. Okay. All right. So I'm going to do a second experiment now. I'll come back to those two figures in a second. Second experiment now. And I'm going to actually use this piece of string to measure the diameter. I'm going to get a pair of scissors. I'm going to cut it. Oh, where's the scissors gone? Just move them. All right, so just cut the string round about here, I think. All right, so that should be about the diameter. Now, I'm getting to this number that a few of you talked about, pi. If I start to put this diameter around the outside of the shape, many times it will fit in. So let's say from here to here, it's going to fit in many times?
Like 3.14.
You think it's going to fit in 3.14? Well, let's see. That's once. Around to there is twice. Okay, that's twice. So there's my joint. We're fitted once, twice, and around to here. Doesn't quite make 3 times around. And there's a base. Yeah. So there was from here to here was once. From there to there was twice around. And from there to there was 3. And then there's this bit. 3 and a bit. Exactly. 3.14 times. And let's go back to this calculation I did. So 24. Whoops. Low battery. 24 or 27 divided by 8.4. So that's the same. How many of these diameters? Gone a bit fuzzy. Thank you, Asher. 27 divided by 8.4. I know, yeah, it'll focus in a second. Oh, come on. There you go. So if I do 27 divided by 8.4, I should get pretty close to pi. So I get 3.214. Now, why didn't I get pi? My circle's pretty good, but my measurement of it was measuring with a piece of string is okay. There's a lot of cutting and pasting from the internet. Very good. Yes, but I should get around 3.14 if I do it correctly. So pi is that number. Pi is the circumference of any circle in the world divided by its diameter. Any circle, including the Earth. So do type that into or write that into your notes. Oh, I need to move that over a bit. Pi is circumference divided by diameter. And of course, that equals, pi is 3.14159.265 and so on forever. For any circle in the world, from the bottom of your mug to the Earth, to this tape, to your water bottle, to a CD, if you remember what those are, to a record player, to the wheel of a car. If you divide its circumference by its diameter, you will get 3.14159.265 and so on. And you have, Brianna has a video. Yeah, there's lots of cool, this is a song, yeah. That's about as far as I know. Yeah, there are songs about pi. There are, plenty of records for reciting pi. So tomorrow in class, we are going to have a little pi recital competition. Who can recite the most digits of pi? So you can see that if you go to Asher's or Kayleem's chat, you see all those digits of pi. So who can say the right amount in a row? We're going to test you on it tomorrow. 3.14159.265, etc. So it's voluntary. If you don't want to do it, you don't have to. It's just for fun. It's just for fun. So if you have time, do it. If you don't have time, it's okay. I'll give you a few minutes at the start of class tomorrow to have a go. Try if you want, okay? It's important that you have some decent notes for today. So hopefully I'll leave this up for a second.